Hey boys and girls, it's Mr. Giomini coming to you with a little bit of review on scatter plots. This is a new graphical representation for you, so I thought it'd be beneficial if we had an extra example or two to help you out as you prepare for your assessment this week. So taking a look, I've taken 10 students, grouped them by their height, found out their height, and also their math score. And notice I have labeled the height as in centimeters, so I labeled that on my x-axis, and the math score is in percent, so I put that here on the y-axis. I looked at this data and tried to figure out what are some good intervals to use. So the math scores, it's easy to do by tens. For the height, I kind of jumped to 140 and then decided to go by tens. So I could probably have a little broken line here to show that I made a jump from 0 to 140. I'm going to start to plot these different students. So we have Albert 180, 56. So Albert 180 on the 180 is his height, 56 is on his assessment. So he's right between 50 and 60. So there's Albert. I'm going to cross Albert out or put a little X here so I know that I've plotted Albert. Beth is 176, so close to Albert's height, and a 29%. So Beth is right there. Put X there. Cindy's 144 and 45. 144 and 45. Okay, right now as I plot the points, I'm seeing that they're kind of spread out from each other. So I want to kind of, as I plot, think about if there's any correlation. David, 195 and a 93. So David, not only tall, he did well in the assessment. We have Emily, 159 and 67. 159 and 67. So she's close to 70. We have Frank, 185 and 38. So Frank, very tall, but didn't do too well in his assessment. Gary, 166, so approximately midpoint here, and 85. We have Helen, 173 and 77. 173 and 77. And we have Ida, 149 and 56. And finally, we have Jeremy, 168 and 71. Sorry, 168 and 71. Now, as I look at this, I see the dots, the points, the plots are very spread out. They're all over this scatter plot. So to me, there is no correlation between your height and what you're getting on a math score. And to kind of even look at the data, I see that David was the tallest kid and he had the highest score. Okay, so maybe it's for as your height increases, your score will increase. So that'd be a positive correlation. The next tallest kid's 185 centimeters, and their score's an 83. That doesn't really correlate too well with the 195-93. The next tallest kid is a 180 and a 56. And then we have a kid who's 173 and 77. So really, if we had a positive correlation, that means this would work. But then these two would need to be taller or have better scores, I apologize, than this person. So there really isn't a positive correlation here, nor is there a negative correlation. There is really no correlation at all, so I would state that no correlation exists between how tall you are and how well you will perform on an assessment. So for this scatter plot, there is no correlation between a student's height and their math score. Okay, nice complete sentence. And I can go on to say that, there exists no pattern between the two separate pieces of data. Okay. Let's take a look at another example here. We have math score 100 meter dash. You notice I have the exact same students. Now I've taken their math score in percent and their 100 meter dash time in seconds. So again, we're going to plot these points, see if we can find some kind of correlation. So Albert, 56 on his test and a 11 and 3/10 of a second 100 meter dash. So 56 and 11.3. We'll plot that right about there. I'm going to slide Albert just a little over as far as his math score goes. Okay, this is nice and easy when you use the graph paper. It helps you out when you're doing this unless you're eyeballing it. So Albert's done. Beth, she had a math score of 29 and was fairly slow in the 100-meter dash. She almost ran in 13 seconds, so Beth would be towards the top. We have Cindy, 45 and 11 and 9/10 of a second. So 45, she's close to 12 seconds. 45 and 11.9. Okay, there we go. We have David, 93 is the math score, and he so far ran the fastest time. 93 and 10.2 seconds, or 10 and 2 tenths of a second. I'm tongue-tied here. 93 and 2 tenths. There we go. We have Emily, 67 and 11.1. 67, 11.1. We have Frank, a 38 and a 12.5. We have Gary, an 85 and a 10 and 8 tenths. It's pretty good. Let me slide Frank over just a little bit there. I'll erase this. Okay. We have Helen at a 77 and a 10.5. 77 and a 10.5. We have Ida at a 56 and a 12 flat. And then we have Jeremy, who had a 71 and also a 10 and 9/10. 71 and 10 and 9/10. Now, taking a look at this, if I try to find a line of best fit, and let me get a different color here, or a trend line, it appears to be that if I were to draw a line, a lot of these numbers seem to hover around this line. And I could kind of slide this down a little bit. I want to try to hit as many points as I can. And I think that's my best trend line or line of best fit. Now, looking at that, according to this, as your math score would increase, your 100-meter dash time would decrease. So that this scatter plot stating that there is a negative correlation between your test score and your 100-meter dash. And I say it would be negative because as your test score increases, your 100-meter dash time decreases. Now, there's also things called correlation does not equal causation. There is no, we should know that really, no, it doesn't matter how fast you are, that doesn't affect your math score. So sometimes you have these kind of false piece of data here that says, yeah, how fast you are is correlated to with your math scores. Well, that doesn't exist. So this is what we call a correlation does not equal causation. So your math scores do not cause or does not affect how fast you are. Okay, so this would be a negative correlation based on this, but we should know too that there really is no correlation between how well you score an assessment and how fast you are in the 100-meter dash. I did want to show you this because you got to be careful. Sometimes you can't just say, oh yeah, that works. Because it says in the graph, Mr. Giomini, you have to be careful because sometimes people will take the data and make it read how they want it to read. Hope this helps you out with scatter plots. Take care.